It's kind of connect to the server, so.
I'll deal with this. What you work with Tom on beers while.
Then
One, two, three, streams on. Okay, welcome back to Night Hacking's live stream from DevOps 2015. So with me is now Michael Hoffer from the Goethe Center for Scientific Computing in Frankfurt, I think.
yeah,
So he's doing lots of cool stuff like a 3D printing, but he's not here for 3D printing this time. He's here for like showing you like visual programming environments, and it's like very awesome. So, but can you tell me about what you're doing for a day job?
yeah. So as a day job, I do workflow management systems and visual programming environments based on the Java platform, and we usually do that for managing complex simulation systems. So that basically systems that we write in our institute, and yeah. So after some time, I discovered that it might be better to create a general purpose programming environment. So I created one Swing-based environment over the last few years. It has a nice plugin system and it's based on Groovy. And then I even went further in my PhD work, working closely with the Groovy compiler and getting all the information from the compiler to really visualize data flows and control flows. And yeah, so that is kind of.
This sounds like we need more visuals about that. So
Yeah.
not talking is not enough, probably.
That's- yeah,
So
that's
let me put you on the screen. Let's see. Okay. So now your screen is live. So
Yeah, so this is
show us something.
the visual programming environment that you can also download. It's called VRL Studio.
So I assume it's on GitHub.
It's of course also on GitHub, but you can also download just binaries for every
Okay.
major platform. And we also ship installers for Windows. And so let's get started with the basic idea. So one problem visual programming always has is who does actually define what components are available. And so my goal was always to be close to the actual target platform, and in this case it's Java. So what we do here is we instantly visualize interfaces of classes that you can define at runtime. So it inherits some ideas from Smalltalk, for example, because we serialize all object state you see here. So when I compile this class and create an instance, I immediately get a user interface.
Wow.
And I can directly invoke a method, and I can invoke it multiple times if I want. So this is actually very good for teaching programming also, and also for like figuring out what the program actually does. Because usually when you have a program working even with workflow environments, it's not very easy to like get the description of these blocks here and what would be better than source code. So our DSL is actually just Groovy or Java source code. So you can easily exit it again. And then here's another example. So we just look at this add method here. So I don't know, maybe I zoom in a little.
Maybe let me switch to full screen.
Yeah.
Okay, so it should be
So
good now.
No, it's better.
Yeah.
So here we have one add method. If I compile it, I can also create an instance instantly, and then create new windows. And now I can even do data flow programming. So I can add some input values here, forward it to that one, and then if I invoke here, it will invoke all dependencies here. So
that's cool.
Maybe I go up a little.
So it reminds me like things like Simulink and.
Yes, and the cool thing here is that you can do it with any Java object that is on the heap. So everything you instantiate can be directly visualized. It does it by Java reflection, and all these components here can be defined by using annotations if you want. So you can replace these default visualizations and use a slider instead, or what you can see here, a 3D visualization. So this is just
so
a
this
library.
looks like your objects you're printing?
Yeah, this is for the printing environment. So yeah, it's just a library called JCSG, so it implements a specific geometry generation algorithm. And all these objects here are just visualizations of library objects, basically. So it's just an API, a little bit annotated, and you get directly a visualization. So I just had to write one plugin for the 3D visualization.
Wow.
And everything you see here is also this here, for example, it's just from the library. And maybe one more example in this environment, a color chooser in Swing. So that is something that was actually not so easy to program in Swing, but for us it is, because here we just have basically one line. We just create a color object, and then you have this RGB.
Yes.
And you just say, I want a slider. And if I compile that, I get a color chooser. So I can now choose a color. If I invoke it, it will return the color. So that's how.
So you can apply that color to the object, or?
In this case, not, because we are not printing multicolor, and the color is just for visualization. But we
multicolor would be nice.
Yeah, that's true. Yeah. So,
all right. So you just told about in this environment. So you have another environment.
Yeah. So we have another.
This is like very awesome already. So you're just going to go even further.
Yeah, we can go even further. So fasten your seatbelts. It's going to be more interesting.
That's
even.
Awesome.
What you saw up till now is really convenient for many situations. But if a programmer really wants to map source code to a user interface, you still have to have a control flow and data flow and everything. So I thought, why not use the full information available from the compiler? Because usually we compile programs, we even have AST transformation and stuff, but when we're done with compiling, we basically throw that away. And just the effect of the transformations, they remain in the bytecode like Groovy does. You can like automatically add methods or do some logging or stuff like that. So you have different annotations, and that's really convenient. But still, this is not enough in my opinion, because an application is much more than just transforming an AST in a way, because you have to connect to a user interface or to some interactive parts. And so also here my idea was, why don't use the information from the compiler to directly communicate with the user. So what you see here is a direct visualization of the source code. This is a Java FX-based user interface. It's still a prototype. So you can also download that on GitHub, but yeah, as it is a prototype there, you have to compile it yourself at the moment.
Shouldn't be a problem.
No, it shouldn't be a problem. It's Gradle-based, so it's really straightforward. So I can zoom in even. And what you see here is now just a class called B. It's this class we can see here on the left side.
Yeah.
And now I can change this source code. And now it says, hello Groovy. So we have a really bi-directional mapping between source code and user interfaces. And this user interface could actually be used by even unexperienced programmers, because they cannot destroy the program. They cannot introduce syntactic errors into the language. And also this editor knows about everything you do, so it can select the visualizations based on the visualizations you do in the text editor.
So this is all Groovy based?
That's all Groovy based. So the other environment was also Groovy based. It used Groovy as a programming language, and I used the Groovy compiler API already, but this here is pure Groovy in a sense that you still access the whole JDK and everything, but I used the Groovy compiler to get all the information.
But by any chance you're going to do this for Java as well, or only Groovy, or going for Scala or Clojure? Or,
yeah, so actually I started with Groovy because it's so accessible, and I only did a subset of the language yet, because I I want to prove a point here so that the whole concept works, and after that I would scale that up to actually full Java. That would be my first target. So what I do is actually a subset of Groovy, which is like also a subset of Java in a sense. So we have a few exceptions, so you can leave out like modifiers and stuff, but basically we use Java syntax.
So trying to get a prototype working on a couple of things that are valid Groovy and valid Java, and then taking it further for and expanding it to the whole space.
The thing is, when you only talk about it, then people really say, yeah, is it worth the effort? I don't really understand whether that would be beneficial.
Yeah.
But when you really show a program when it's running, they usually get the idea. So probably we should do that here as well. So if I run the program,
wow,
I really get the intermediate
results. Like every object result is like rendered?
Everything is rendered in JavaFX. So in this case, that's why we do also 3D printing, because it's a very nice application of that environment. The thing is, we instrument the whole thing here on a language model base. So we don't instrument the bytecode, but we add instrumentations to the actual source code. And by that, we can even do selective instrumentation and also optimizations if we want. And what you see here is also the profiling information. So this red box here executes all the other methods here. Actually that's the one that takes most computational wise, takes up the most time, but these are actually executed in that method. And you see we don't touch class A or B. So you also get a sense of code coverage.
Ah, okay.
So
you can visualize code coverage?
Yeah, this is actually visualization of code coverage. I mean, we don't have special visualizations like how often you go through one path or something, but you still get kind of a feeling where code gets executed and where it doesn't. And the cool thing here is, I mean, if you see that user interface, this is, like you saw in the earlier examples, just a regular user interface. You could ship that as an application, basically, if you had an application that does complex computation.
Yes.
And it's just one method call here on the left-hand side. I mean, it's just this one.
Wow.
And so, in a way, it's much simpler than many other environments because you only need just a couple of lines of source code to get a full-blown user interface, and you could apply it to different problems domains and add your own visualizations. And then you have like a visual debugger on steroids, because no debugger would tell you whether this geometry is the one you want or not. So you have to have some visual feedback. And also humans tend to actually think visually. So what I also like, if somebody doesn't know programming, you still see the intermediate steps here. You can instantly describe what you do. I create a cube, a sphere, and this is the difference of it. So it kind of documents itself. And I also like the fact that you can zoom in and out of
that's awesome. Very, very, very nice. So this is a prototype status? You can try it out if you
you go to GitHub and then you can just check out the VRL 0.5 branch there, and then you can just try it out. There is it's a multi-project build, so I can show it here. And here we have a VRL UI project, and if you run that, you get exactly the same visualizations we saw there.
So we will put the link to the repository in the show notes, so people can easily figure it out and download it and get started.
And please give feedback if you have any ideas about that. It would also be great to develop that in a greater, bigger community. And
so that's good. So very nice having you here. So any special things you're doing here at Devox besides doing 3D printing stuff?
Yeah, I have a talk on algorithmic 3D modeling tomorrow. So there we will have some fun with this environment on also 3D printing, and we talk about visual programming a bit and how it could be evolved.
Okay, so a good tip for everybody here at Devox, come go for this talk. You will be very visually well.
Yeah, that's true.
That should be good.
Yeah,
okay, thanks for being here with us.
Thanks for having me. And
so welcome. So on the beer protocol.
The beer protocol.
Cheers, man.
Cheers.